So once we put our matrix into the calculator and have it solve it for us, then it spits out this red matrix here, as long as we turn our answers into fractions. And if we don't, then we'll be in for quite a bit of pain. Okay, so let's take a look at this first line here, which makes our first equation. It basically says that A, everything else is 0, B, C, D, E, F, G, H, but then I have an I, minus 5/94 I is equal to 0. That doesn't look like a 0. How about now? Okay, now take a note here. Notice how this column for i's is the only one that has numbers other than 1s and 0s, which means that it might be easiest or advantageous to let k equal I, not 6. Okay, so when we do that substitution, A minus 5/94 k is equal to 0. Just add that 5/94 k over. A equals 5/94 k. That's it. Okay, so we have our A value now. We have our A, we have our I. Now to get the rest, all I have to do, just notice, all I have to do is just add each one of these things over to the right-hand side, since I just said that I was equal to k. So, in that case, B is equal to 61/94k. C is equal to 299/188k. D is 81/94k. E is, make sure I line this up right, looks like that's 5/188k. F is 61/94k. And G and H are both the same at 15/47. Okay. 15/47. Alright, so that gets us equations for every single one of the variables. Now what we have to do is we got to pick a value for k to make all of these fractions disappear. The reason why is because when we're looking at this chemical equation, you can't have, say, a half of one of these molecules, because that didn't make sense. We can't break that molecule in half. Okay, we're just rearranging all of the atoms in each one. So the easiest way to do this is, of course, to get the least common denominator. Least common denominator of all of the fractions is, in this case, 188. So what we're going to do is we're going to let k equal 188, and then we're going to get the values for each of the other variables when we substitute 188 in. Okay, so for A, 5/94 times 188, the 94 goes into 188 twice, so leaving 5 times 2 is 10. So my A value is 10. So I have 10 of those. Okay, for my B value, 94 and 188 will cancel, leaving it 2. 2 times 61 is 122. So my B value is 122. 122. C value, the 188 will just totally cancel, leaving me with 299s of these C's. Could you imagine trying to find that by guessing and checking? 299. Okay. On D, 94 and 188 will cancel, leaving it 2. 2 times 81 is 162. 162. Now we're on to E. We're almost there. 188 will just completely cancel, leaving us with a 5 for E. 5 of those. Okay, 94 will cancel, leaving a 2. 2 times 61, we already did that, as 122. 122. Okay, and these last two are going to be exactly the same. 47 goes into 188, I believe, 4 times. Let me double check. So 188 divided by 47. Yep, 4. So 4 times 15 is 60, so that's 60 for both of these. A 60 here, a 60 there. And the last one is I. We said I is 188, and then that balances the equation. So let's just take a second here to see how you can check to see if your balancing is done successfully. So let's pull up another color. How about pink? Okay. So just for example, let's just take one of these elements at a time. Okay. So let's take the K. So 4 times 10, I have 40 of these. And this one is 122, and that's all I have on the left-hand side. So 40 plus 122 gives me 162. If I look over here on the right-hand side, my K is 162. So that balances. And you can use that process on each one of the atoms to check to see if it balances. Let's do one more. Let's do Fe. There's 10 of these, 10 FEs on the left-hand side, and on the right-hand side there's 2 times 5, which is 10, so that thing balances as well. And so on.